Okay, continuing 4.3 and 4.4, you have a logarithm function, which is log base a of x, f of x equals or y equals, where the base has to be positive and the base cannot be 1, and the guy you take the logarithm of has to be positive as well. These guys have two values, two functions, or two graphs. If the base is bigger than 1, it goes up and to the right. If the base is less than 1, it goes down and to the right. This is the inverse of exponential, essentially how it works. So just if the base is 2, it goes in this direction. The base is 3, the base is 4, the base is 5, and so on and so forth. It goes this direction. If the base is less than 1, like 1/2, 1/3, 2/5, 3/4, that kind of thing, it goes downward. Now, if it's natural log means it has a base of e. Natural log, essentially, is this button, your calculator. Now, if I go to the graphing function, I don't know how this is going to work. Let's see. If I go natural log, so you can kind of see it. See how it kind of goes up and to the right? So your natural log kind of does this number. It's more steep, but this is the idea. And has a base of e. A base of e. Okay, just want to throw it out there. Uh, if it's, again, e has 2.7, so if the base is bigger than 1, it goes up and to the right. If the base is less than 1, it goes downward and to the right. Just to kind of add on to that here, just to kind of show that here. Then we talk about the movements, the translations. Now, minus, like in the previous, if you have a minus trapped inside of parentheses with the logarithm, that's to the right. A plus means to the left. So it's going to turn out that all these guys are going to pass through 0, because as it is, as it were, you think the logarithm of 1 is 0, because for exponents, remember the critical point was 0, 1, because remember exponents, when you when you raise it to the 0 power, you get a 1. Well, that's the point 0, 1 in the previous graph. But remember what the inverse does. The inverse turns it. So log of 1 is 0. It's the actual inverse of an exponent, is what it is. So logarithm is the inverse of an exponent. That's why the critical point is 1, 0. So if the graph moves to the right, then 1, 0, you add 1 to the 1 because you change the x value. So 1 plus 1 is 2. So it just slides over 2. But now the asymptote, these guys have a wall at the y-axis, what's called a vertical asymptote. This is stuck. The previous one, exponential, had a horizontal, had the x-axis, but the x-axis becomes the y-axis when you take the inverse. So this is the horizontal asymptote for the exponential becomes the vertical for the logarithms. So if the vertical is attached to the logarithm. So if you go 1 to the right, the asymptote moves 1 to the right. If you go 3 to the left, the asymptote moves 3 to the left, as does the graph. So 1, 0 becomes negative 2, 0, because 1 minus 3 is negative 2. So you're talking about a shift to the right, shift to the left. If you throw a number out in front or at the end, positive means up, negative means down. So 1, 0 goes to 1, comma 4. 1, 0 here goes down to 1, negative 2. But the asymptote stays intact. If you move up or down, you're just going to slide up or down. The asymptote stays vertical. I mean, if the vertical asymptote stays the way it is, the graph just slides up or down. If you were to move right and left, then the asymptote moves right or left. A number in front means to flip. So it's a vertical reflection. You stick a negative in front. Let's see if I can do it here. See if I can do this. See. So this is the original graph, what it would look like. In fact, I'm gonna put it here with you. I'll put it as well here. Let's say natural log here. Let me specify here. That's the original graph. This is the original graph, logarithm of 6. But if you flip it, it's going to be the one going down. So this is the flip. So you flip it. You take it off. So you can see that's how it ends up. Flipped. Okay? So it means vertical reflection, essentially, or about the y-axis. So again, what does a logarithm mean? It means a log base a of x means a raised to what power is x. It's the reverse. So if you talk about log base 2 of 8, it means 2 multiplied by itself. How many times did it take to get 8? So 2 raised to what power is 8? 2 to the third power is 8. So log base 2 of 8 equals to 3. Log base 5 of 25 is equal to 2 because 5 to the second power is 25. Log base 3 of 81 is 4 because 3 to the fourth power is 81. So essentially a logarithm is the inverse of an exponential problem. Okay? It's the opposite of an exponent. Now the bottom part here essentially has just problems here with the calculator. Now you have two buttons, log and an ln button. This asks for log of 100. Just the way you see it. Okay? Log 26. The 3 decimal places. Log of 1 we know because log of 1 is always 0. Natural log of 200. This is just so you can practice with the calculator. Natural log of 1.25. You can have 4 decimals. And then natural log of 1. This is just so you can practice with the calculator. You're going to need a calculator for this section. If I haven't already mentioned, you need a calculator for this chapter. I'm mentioning it now. You need a calculator for this chapter. Okay. Next page, we have what's called a change of base formula. Now, change of base formula allows us to kind of change everything to division problem. So I'm not really giving you the formula, but I'm showing you how to use it. So if you look at log base 2 of 37, the formula says, or the rule says, 37 comes up here, and the 2 comes down there. And you can change it to any base you want. Now, you have any base you want. I'm going with the base in your calculator down here, ln. Or you can also change it to log, and the next one has log as well. So I can show you it's either one, but put in the 30, I'm showing that it has to be log of 37 over log of 2. I'm going to show you both. Log 37, parentheses, divided by log 2. So you see I get the answer? Now I'm going to do natural log of 37 divided by natural log of 2. Same answer. So you can't mix and match. You can't say log divided by natural log because log is base 10, ln is base e. Again, ln is called natural log. Log with no base here means a 10. It's what's called a common logarithm. This is a base of 10. So I just wanted to show you there's a nice little formula there. For the second one, see a log base 1/2 of what is that, 12 over 19? So I'm going to do log parentheses 12 divided by 19 divided by log of 1 divided by 2. Was that 19 or what the heck is it? Oh, sorry, I forgot the 9 there. Excuse me. Log of 12 divided by 19 divided by log of 1 divided by 2. Let's try that again. 0.663. 0.6, I did 3 decimal places. And then the last one you can verify it as well. I'll do natural log of 88,000. Hope I punch this right. 296 divided by natural log of, what was that, 271? And so on. Because it's just calculated. It's real nice. Um, the last part of this is kind of weird because you're going to move things around. You're going to expand and you're going to condense. So rule 1 says if you have the log of two things multiplied, it becomes two logarithms with those two things inside added. So multiplication goes to addition. The opposite of multiplication is division. Division should go to the opposite of addition. Sorry, the opposite of multiplication is division. The opposite of addition is subtraction. So multiplication goes to addition, division goes to subtraction. The exponential one comes in front. So the power I can put in front, or I can actually put the number in front as a power. I can take two logs that are subtracted and make it into one log that's divided. I can take two logs that are added and make it into one log that's multiplied. It's weird. But here I have log base 2 of 7 times x. So I can write it as log of the 7, log 2 of 7, plus log 2 of x using the first formula. Division, log base 8 of 3/5. Log of the top minus log of the bottom. So I do log base 8 of 3 minus log base 8 of 5. That's it. The exponent here, x to the 9th. Rule number 3 says I can put the 9 in front. That's all it says. So if I have the natural log of two things multiplied, x squared and y to the third, I separate it to addition because multiplication goes to addition. But in each one, I still have powers left. So I'm going to use the third rule and put the power in front. So 2 natural log of x plus 3 natural log of y. Here I have the same thing as number 5, but essentially I'm dividing. So it's the top minus the bottom. Natural log of 8 to the 4, log base 5 8 to the 4 minus log base 5 of b to the third. But these are powers individually, so I put a 4 in front of this log, a 3 in front of this log, and I get my final answer. It's weird, but that's all you're doing. You're moving things around. You're not solving anything. For this one, I did it in one step because the bottom is divided. So the bottom, you see how the C and the D, because they're getting divided, they get subtracted. Division goes to subtraction. The stuff on top is multiplied, so they get added. Sorry, the numerator, the stuff's on top, so that's addition. The denominator, stuff on the bottom, is divided, so minuses. So log of A plus B minus C minus D. The numbers here in front are the powers. So it's 2 log A plus 3 log B minus 5 log C minus 4 log D. And that's what's called expansion. We're making everything bigger, wider, using essentially the formulas. Well, now this side says, well, if you can go from a 1 to multiple ones, you should be able to go from multiple ones back to this way. So if I have addition, I should be able to go back to multiplication. So two things that are added, I should be able to make it one thing, and those two things multiplied. So log base 3 of 8 plus log base 3 of y becomes log base 3 of 8 times y, one logarithm. Addition goes to multiplication, so subtraction should go to division. Log base 4 of 6 divided by x, because they're subtracted. The number outside, again, remember, the exponent comes in the front, which means the number can come back as the exponent. So this 3 becomes the third power for y. That's all it is. So 1/2 comes in front of x, 6 comes in front of y, powers, but I have addition, so these two get multiplied. So this should be x to the 1/2 times y, but x to the 1/2 power is actually the square root of x. Subtraction, well, you have numbers out here, so they become their powers. So it becomes a to the 4th, b to the 8th, minus means a to the 4th is on top of the fraction, b to the 8th is on the bottom of the fraction. And here you have 4 things. Again, these two things are added, so x and y are on the top. These two things are subtracted, so a and b are on the bottom. 3 is the power, 2 is the power, 4 is the power, and 6 is the power. So log base 5 of x to the third times y squared divided by a to the 4th divided by b to the 6th. That's essentially how 4.4 works itself out along with 4.3. So it's really just kind of manipulating logarithms.